Welcome to the beginner video series for the GRE. In this video, we are covering the chapter geometry, and in that the subtopic is triangles. Now, triangle is a major subtopic in geometry. So we have made many videos of triangles, and this is the first installment of the video series. The first concept is sum of internal and external angles. Let's say this is a triangle whose internal angles are ABC. Now in a triangle, always the sum of internal angles is equal to 180 degrees. So A plus B plus C is equal to 180 degrees. In any triangle, sum of internal angles is always 180 degrees. Now you get external angles when you extend the sides. This is an external angle, let it be P. This is an external angle, let it be Q. Now external angle is not this entire angle. You only get external angle when you extend the side. So this R is another external angle. Now there is a property in triangle that any external angle is equal to the sum of the opposite two internal angles. So P is equal to B plus C, because for P the opposite internal angles are B and C. Any external angle is equal to the sum of the opposite two internal angles. For Q, the opposite angles are A and B, so A plus B. R is equal to A plus C. Now if we add PQR, there are two A's, two B and two C's. So 2 times A plus B plus C, and we know the value of A plus B plus C, which is 180 degrees. So this is 2 times 180 degrees or 360 degrees. So sum of external angles in a triangle is 360 degrees. Sum of internal angles we have already calculated is 180 degrees. Now this was about triangles. If we take any other figure, any other polygon, let's take a rectangle. A rectangle is a quadrilateral. It has 4 sides. Now all the internal angles are 90 in a rectangle. So sum of internal angles in a rectangle is 360 degrees, because 90 times 4 is 360 degrees. Sum of internal angles in a triangle was 180 degrees. Sum of internal angles in a rectangle is 360 degrees. So the sum of internal angle increases with the increase in the number of sides. And there's a formula through which you can determine the sum of internal angles in a polygon. Sum of internal angles is equal to n minus 2 times 180 degrees, where n is the number of sides. If you know the number of sides, you can find the sum of internal angles using this formula. For instance, triangle has 3 sides, so 3 minus 2, which is 1. 1 times 180 is 180 degrees, which we got here. A rectangle has 4 sides, so 4 minus 2 is 2. 2 times 180 is 360, which we got here. So using this formula, you can find the sum of internal angles for any polygon. Now let's find the sum of external angles. You get external angles when you extend the sides. Let's do that. This is 90, this is 90, this is 90, this is 90. So sum of external angles here is 360 again, because 90 times 4 is 360. In triangle, the sum of external angles is 360. In a rectangle, it's again 360 degrees. If you increase the number of sides, the sum of external angles will remain 360. For any polygon, the sum of external angles is always 360, no matter how many sides it has. Even if it has 100 sides, then the sum of external angles will still be 360 degrees. But sum of internal angles changes with the increase in number of sides. Let's move ahead to the next concept, which is about minimum and maximum side of a triangle. Now I want you to think about this question. Pause and give this a try. I hope you have done so. Now let's do it together. We are told there is a triangle with two sides 6 and 8, we have to determine the range of lengths that the third side x can take. Okay. So let's take any side as the base. Let's take 8 as the base. This is 8. Now 6 is attached at this vertex. This is 6, and this is the third side. Now let's say I bring this 6 closer to the base. I bring this 6 closer to the base. What do you reckon happens to the third side? It reduces, it decreases, the length of the third side decreases. If you bring this further closer, the third side further decreases. Now there would come a point when 6 is almost on top of 8, almost on top of 8. In that case, this is the third side. So this is how the triangle looks like. This is 8, 6 is almost on top of 8. This is the third side. It almost becomes a straight line. Okay, it almost becomes a straight line. In that case, this is 8. The second side has length 6. The third side would have length 2 because it's almost a straight line. So 6 plus 2 is 8. So the third side can have the minimum length as 2. Okay, and that is the case when 6 and 8 are almost on top of each other. The triangle is almost a straight line. The third side cannot be 2 because in that case it will cease to be a triangle. It will become a straight line. So the third side can be anything greater than 2. Can be anything greater than 2. Now let's do another thing. Let's take this 6 away from the base. Let's take this 6 away from the base. As you take 6 away from the base, you will realize that the third side increases. You take it further away, the third side would further increase. Now there would come a point when 6 and 8, they almost form a straight line. They almost form a straight line. Not exactly, but almost form a straight line. In that case, the third side has length 14 or slightly less than 14. Okay, this is the case. This is 8, this is 6. It's almost a straight line. The third side has length which is 6 plus 8, 14. So the maximum value of the third side is 14. It cannot be 14 because then it won't be a triangle, it will be a straight line, but it can be anything less than 14. I hope this is clear. Slightly complicated, but you can watch this again if you did not understand this. So there is a formula which you should remember, and that is any side of a triangle is greater than the difference of the other two sides and less than the sum of the other two sides, which we can apply here also. X is any side of this triangle. X would be greater than the difference of 6 and 8. The difference is 2 and less than the sum of the other two sides. Sum of 6 and 8 is 14. This is very important, and we have also seen how to derive this. When 6 is very close to 8, then the third side is minimum. The third side would have length 2. When again 6 and 8 almost form a straight line, then the third side is maximum. In that case, the third side has length 14, which is the sum of 6 and 8. So please remember this. Any side of a triangle is greater than the difference of the other two sides and less than the sum of the other two sides. Very important concept. We'll move ahead. Which of the following set of values can represent the dimensions of a triangle? I want you to try this using the concept that we just learned. Pause the screen and try it. I hope you have done so. Now let's solve it together. We know any side of a triangle is greater than the difference of the other two sides and less than the sum of the other two sides. For the first case, let's take any side. Let's take 5. 5 should be greater than the difference of 5 and 10. Difference is 5. Now is 5 greater than 5? No, it's not. So this won't be a triangle. You cannot have a triangle with sides 5, 5 and 10. Let's take the second case. Let's take any side 10. Is 10 greater than the difference of 5 and 4? Yes, it is. 10 is greater than 1. Is 10 less than the sum of 5 and 4? No, it's not. So you cannot have a triangle with sides 5, 4 and 10. The third case, let's take 10. Is 10 greater than the difference of 5 and 6? Yes, it is. Is 10 less than the sum of 5 and 6? Yes, it is. So this will form a triangle. You can have a triangle with sides 5, 6 and 10. Okay, we applied this property. Any side of a triangle is greater than the difference and less than the sum of the other two sides. I hope this is clear. We will move ahead. Right angle triangle, Pythagoras theorem. Now here let's say the three sides are ABC and x is this angle. If x is equal to 90 degrees, then a square plus b square is equal to c square. This is the Pythagoras theorem. It states that base square, this is base, plus height square is equal to hypotenuse square. C is hypotenuse. Base square plus height square is equal to hypotenuse square. Now this was about Pythagoras theorem. This was about right angle triangle. But let's say I increase angle x. What will be the relation between a square plus b square and c square? Considering that c is the longest side. Considering that c is the longest side. Give this a try. Okay. Let's see. Let's say you keep a and b the same. You only increase angle x. Okay, you keep a and b the same. You just increase angle x. What will happen to c? You have kept a and b the same. You have increased angle x. Now this is greater than 90 degrees. You would realize c would increase. So c square would be greater than a square plus b square combined. Again, let me reiterate. In this case, a square plus b square is equal to c square. But if you increase this angle, keeping a and b the same, c would increase. So c square would get greater than a square plus b square. Let's take the opposite case where x is less than 90 degrees. What is the relation between a square plus b square and c square? Okay. Now let's say you have kept AB the same. You have just decreased this angle. This angle is now less than 90 degrees. Now you would realize that C has also decreased. C has also decreased. So C square is less than A square plus B square. Right? So in a right angle triangle, the sum of the squares of the two smaller sides is equal to the longest side. In an obtuse angled triangle, obtuse angled because one of the angles is greater than 90 degrees. In an obtuse angled triangle, the sum of the squares of the two smaller sides is less than the longest side. This is an acute angled triangle in which all the angles are less than 90 degrees. In an acute angled triangle, the sum of the squares of the two smaller sides is greater than the square of the largest side. Okay, I hope you've understood this. Let's move ahead. Now we'll discuss about two spatial triangles. All the triangles which have angles 30 degrees, 60 degrees and 90 degrees are called spatial triangles, and all the triangles which have angles 45, 45 and 90 are also spatial triangles. Why are these two types of triangles spatial? It's because we know the ratio of sides for these two triangles. In any 30, 60, 90 triangle, this will be the ratio of sides. Root 3 is to 1 is to 2. Opposite to 60 is root 3. Opposite to 30 is 1. Opposite to 90 is 2. So the ratio is root 3 is to 1 is to 2, where root 3 is opposite to 60 degrees. Opposite to 30 is 1, opposite to 90 is 2. We'll discuss a question in which we see the application of this ratio. In a 45-40 of 90 triangle, the ratio is 1 is to 1 is to root 2. Opposite to 90 is root 2. Opposite to 45 degrees is 1. Okay, you have to memorize these ratios. Geometry is unlike other chapters where you do not have to remember a lot of stuff. The chapters are hugely based on logic, but in geometry, apart from logic, learning or memorizing a lot of formulas is equally important. Let's see the application of the spatial triangles. This is a 30-60-90 triangle, and give this question a try. Pause and try it. I hope you have done so. Now let's do it together. We know the ratio of sides of 30-60-90 triangle. Opposite to 60 is root 3. Opposite to 30 is 1. Opposite to 90 is 2. Now we are given that the side which was supposed to be 2 is 7. Now how do we make 2 into 7? We know the ratio is root 3 is to 1 is to 2. The side which was supposed to be 2 is 7. How do we convert 2 into 7? Now we can divide 2 by 2, which will make it 1, and then multiply by 7 to get 7. So we will do this to all the terms in the ratio. We'll divide 1 with 2 and multiply by 7. We'll divide by 2 and multiply by 7. So this will become 7 root 3 by 2. This will become 7 by 2. Now take note, multiplying and dividing by the same things to all the terms in the ratio does not change the ratio. The ratio is still root 3 is to 1 is to 2. Okay, multiplying, dividing the same thing to all the terms in the ratio does not change the ratio. So if AC is 7, AB will be 7 root 3 by 2 and BC will be 7 by 2. Okay, I'll explain it again in case some of you might not have got this. I'll explain this again. We know the ratio of sides in a 30-60-90 triangle is root 3 is to 1 is to 2. Now we are told that the side which is supposed to be 2 as 7. Now how do you make 2 into 7? How do you convert 2 into 7? You divide 2 with 2 and you multiply it with 7 to get 7. So you do this to all the terms in the ratio. You divide all the terms by 2 and multiply by 7. Multiplying and dividing the same thing to all the terms in the ratio does not change the ratio. So if this is 7, this is 7 by 2, this is 7 root 3 by 2. So AB is 7 root 3 by 2, BC is 7 by 2. I hope this is clear. It's not as complicated as it looks like. Let's move ahead. I want you to pause the screen and try this question also. I hope you have done so. Let's do it together. Here angle A is 120 degrees, B is 30 degrees, C is 30 degrees. We are asked the ratio of the sides. Now we only know the ratio of sides for the two spatial triangles, 30-60-90 triangle and 45-40 of 90 triangle. We do not know the ratio of sides for any other triangle. So what should we do then? We should try to split this triangle into the spatial triangles. You see a 30 degree, suddenly an alarm should go off in your head that probably I can make a 30-60-90 triangle, and you can do that. You have to draw a perpendicular from A and you get 30, 90, so this would be 60. You get a 30-60-90 triangle. Why did we draw a perpendicular from A? Because 120 degrees is of no use. 120 degrees comes in none of the two spatial triangles. So we have to split 120 degrees. Hence I drew a perpendicular from A. This is also 90, this is 30, hence this would be 60. Now we are in some familiar territory. If we assume this is 1, if opposite to 30 is 1, opposite to 60 will be root 3, opposite to 90 will be 2. In this triangle also, if opposite to 30 is 1, opposite to 90 will be 2, opposite to 60 will be root 3. Now we can write the ratio of sides. AB is 2, BC is root 3 plus root 3, which is 2 root 3. AC is again 2. So the ratio is 2 is to 2 root 3 is to 2. You can divide all the terms with 2 to simplify the ratio, and you get the final ratio as 1 is to root 3 is to 1, and that is our answer. With this, we come to the conclusion of this video. See you in the next video. Thank you.